Bom dia, pessoal. Voltamos, então, estamos no ar, agora aqui com a Natalia, da empresa Rated Power. Como foi colocado, né, no nosso cronograma, essa palestra será em inglês, a Rated Power é uma empresa da Espanha, né? Então a gente vai ter essa apresentação em inglês, apresentação internacional aqui. A Rated Power é uma empresa que a gente conheceu no Intersolar dos Estados Unidos, né? E está trazendo esse conhecimento também de fora do Brasil para o evento. Good afternoon, Natalia.
Hi, good afternoon.
Natalia is in Spain, so she's 5 hours ahead of us. We'd like to thank your presence here in the event. It's really nice to have a Rated Power with us. So I will get out of here, but if you need anything, you just say we will be watching you. Okay?
Okay, thank you very much. Okay, so hello everyone. Thank you very much for your time. My name is Natalia, as Brunella said, and I'm a PV project engineer at Rated Power, a Spanish company based in Madrid. I'm going to structure this lecture in 3 parts. The first part, it would be a brief introduction about Rated Power and our product, that is PVDesign. Next, we will do a demonstration on how our software PVDesign works. And finally, we will have 5-10 minutes of questions. If you have any questions throughout this presentation, just leave them on the chat, and I will make sure we will answer them at the end. So about us, Rated Power was born from the experience of the 3 co-founders, which worked for many years on developing basic and detailed engineering of renewable energy plants. They decided to streamline design processes and come with a more efficient and accurate solution. And they created our tool, PVDesign. What is PVDesign? PVDesign is a cloud-based software aimed to optimize the design and engineering of utility-scale ground-mounted solar PV plants. We optimize PV plants up over 1 megawatt. PVDesign allows 1, to assess multiple locations, 2, to try different engineering criteria and equipment, 3, optimize the plant design configuration and compare the results in seconds, and obtain immediately all engineering documentation necessary for a request for proposals or quotation of the EPC. A process that before PVDesign would take approximately 2 weeks or more, now with PVDesign will take only a few seconds. All the documentation we generate is showed here, and it's downloadable and editable. We offer 4 different languages, and those are Spanish, English, Portuguese, and French. Currently, our software has been used in more than 100 countries by our customers, and more than 1,000 gigawatts have been simulated using our software. Some of our clients in Brazil and in other places of Latin America include the companies you can see in this slide. PVDesign is in constant development of new features, and our goal is to create a solution that is as practical as possible. Based on the feedback we get from our clients, we decide to prioritize certain developments above others. For example, we just introduced the energy production using bifacial modules. So next, we will go ahead and dive into our software. I'm going to do a brief presentation as the ones we do for our potential clients, a bit more simplified. So I'm going to be changing through screens. So bear with me, and let's start our experience with PVDesign. So this is the initial interface. We will have here, this is the first screen we're going to see once we enter PVDesign. This is a list of projects, and we will create a new project clicking on this button here. Let's see one that's already been created, as California, for example. First, we need to know what is a project. So I'm going to show you using this figure here. So what is a project in PVDesign? Once you create a project, you're gonna upload your first site, that is this one in the middle, and PVDesign is going to calculate the gravity center of the site. From then on, it will calculate a 3-kilometer radius, and that will be the limit within the client can upload unlimited sites. So what is the first thing we should do? Create a site. Let's go to Google Earth to do so. So we now in Google Earth, and we're going to start creating a site to use in simulate in PVDesign. So to create a site, we will just need to use these two tools that I am showing here. And these are the polygon tool and the position marker. So we will start by first creating a polygon named AA for available area. This is the area in which we will install our PV plant. Next, we will need a second polygon named Esta for the substation. The third element will be an AC point that will be the access point for our roads. And finally, an MV, that is the medium voltage cable drop for our cable drop point for our substation. So from these are the main and basic elements, and we can complicate this as much as we want. We can add more available areas, restricted areas to avoid installing modules in very in areas with with slopes or high voltage lines, etc. Then we should include an AC point for each AA, and optionally secondary access points and medium voltage points for the available areas. Once we have our site, we can go and start designing. So back onto PVDesign, we will start designing. How can we start design? With two options. We can start from zero, start from scratch without any parameter included, or copy one of the designs we have already created. So let's go and do this using this button, Clone Design. We have already uploaded the site that I just showed you, and we have it here, and it can be downloaded in KML or CAD. And automatically, PVDesign will give you databases associated with this site. As you can see, the design interface is configured in 5 tabs plus a preview tab. The first one would be the site details, then civil parameters, equipment selection, electrical configurations, energy yield production, and finally the preview. We have configured the design interface in this way to follow the natural process of PV plant creation. So let's continue. We have uploaded our site. Now we can choose our topography. By default, we give Google Earth topography, and if we click on details, we can see an inclination tool. Through this slider, we can select different ranges for the inclination of our site and can see which parts of our site are more suitable for solar and DC field installation. If we do not want to use Google Earth topography, we can also upload our own topography using a CSV file. Next, we will go on to choosing our meteorological data. We offer NASA Bauer, NASA SSE, and PVGIS5 as default data, but also you can add hourly or monthly TMYs. We follow, again, a CSV format, the same one that Solar GIS uses. Once we choose our database, PVDesign will give you the minimum historical temperature for your site. The two last databases would be the horizon database and finally the surface albedo. You have 3 options, or use the satellite, the NASA MODIS database at default albedo a value, or you can create your own albedo data using this tool. Next, we will go and choose our civil parameters. This is the shortest one of all, so let's see what it includes. First, we will choose how we want our roads to be configured in a layout, horizontally, vertically, or one of these two options plus the perimeter. Then the power station location, roads width, power station dimensions, and finally the structure position. Next, we will choose our equipment. For our PV module, we offer a public database for all our clients that includes almost 3,000 modules. If we click on the Info tab, we will see main characteristics of each one of the modules and its main curves. If we do not include one PV module that you're interested in using on your final design, you can include it to your private database, only available to you by accessing this tab over here. You just need the PAN file if it's a PV module, or OND file if it's an inverter. Same thing for the inverters. We have this Info tab with main characteristics and efficiency and kVA curves. We will choose between central and string inverters, and we can modify the inverter rated power. By default, we give the power at 30 degrees Celsius. If we choose central inverter, we can choose and enable a secondary central inverter. Finally, we will choose our structure, and if we want to use a single axis tracker or fixed structure. After choosing our structure, we only have 4 more inputs to finish our equipment tab. This would be the modules per string. The value recommended here is been calculated with the minimum historical temperature we just saw. Then the pitch distance. If you go changing structures, you can see how this value changes. This value, if we have chosen tracker, guarantees a 40% GCR, and if we choose a fixed structure, will guarantee 4 hours of non-shaded production the worst day of the year. Finally, distance between structures and the minimum ground clearance. This we introduced to better calculate the projection using bifacial modules, and it regards to the minimum separation between the ground and the lower point of the structure table. Next, let's go and choose our electrical configuration. First, we will choose between the 2 cabling size and standards we offer, that are IEC and NEC, and we will set the voltage drop for the DC side and MV system. Next, we will quickly establish the size of the power station, how many central inverters, in this case, each power station holds. Then we can establish the iron and copper loss for the power stations inside each one of, for the transformer inside each one of the PS, the power stations. And next to the connection point, we will set the medium voltage level for our site. Again, losses for the transformer, but this time of the substation, and the overhead line voltage drop. The next thing we have to address is the power factor. Do we have any grid connection requirements? If we enable this feature, we will be able to insert a power factor at the substation input or substation output. PVDesign will calculate a power factor at the inverter output and size our plant accordingly. Next, we have power requirements. This is how PVDesign is going to generate our final result. So basically, there are 2 options. Specific capacity means I'm going to set a number of inverters and a DC-AC ratio, and that's going to be the approximate power of my plant. And if I choose maximum capacity, I am given the order to PVDesign to install as much capacity as it possibly can in my site. So let's choose maximum capacity just to see the power of this software. Next, We will choose the layout configuration. We have regular blocks, adaptive design, or fit design. And this is basically the size of the blocks PVDesign is going to use to cover the ground. So regular blocks will install power station per power station with its DC field associated. Then we have adaptive design for sites that require more detail and that are more irregular, and you want to fit better the available area. And this will install blocks of structure associated to a combiner box or a string inverter, for example. Then for sites which area is below 100 hectares, we have this fit design option that will install structure per structure and afterwards take care of the electrical configuration. So please, now we will choose the electrical configuration for our low voltage system. As we have chosen central inverters, we have these 4 options. And finally, the last input is the strings per string box. As we can see, it says ideal. What does ideal mean? This is that 12 is not going to be strictly the ultimate number of strings per string box. Is the value I'm giving PVDesign that is what I aspire to achieve. So is 1.2 my final DC-AC ratio? No. My final DC-AC ratio and my final number of strings per string box, I will choose from this list of electrical configurations. So as you can see, PVDesign, using all the parameters we have included, will give us 30 possible configurations. If I choose the first one, my final DC-AC ratio is going to be 1.15. I'm going to have 3 strings per individual row, 12 strings per box, 10 boxes per inverter, and finally the size of the block, the block of structures is going to be 2 rows in 1 column. So that's all for the electrical tab. Please, if you have any doubt or I haven't explained myself correctly in any detail, please leave your question and I will be glad to answer them at the end. Great, so let's see our last tab and let's create our design. So our last tab is going to be the energy tab, and here we are gonna set all the values for our energy yield production. So first, losses for my PV module, soiling losses, degradation of my module for the first year and from the second year onwards, module quality, LAD, mismatch. Next, we will set, if we wish to, auxiliary consumption for our inverters. The first value would be the auxiliary consumption as such, then the threshold, and finally, the night loss. For the PV plant losses, we will set a plant auxiliary loss and availability both for the photovoltaic plant, my plant, and the grid, based on a percentage. If I have a limit of active power in my point of interconnection, this is where I will set it. I will, if I have an active power limit of 50 megawatts, for example, I will insert that value, and all energy that's produced over this limit will be discarded and taken into account as losses. Finally, I will set years of simulation or the lifespan of my plant, and that will be all. In approximately 4 minutes, we have done the whole design of our plant. Now in preview, we can see how our plant is going to look like once we press on Create Design. As you can see, there are 2 types of modules, one's in blue and the other one's in red. My modules in blue are 169.9 megawatts peak, and the modules in red are 1.4 megawatts DC. Once I click Create Design, the modules in red will be discarded. This is because with the actual configuration, PVDesign cannot include them. How can I try to include these modules in red to my final result. Just play with PVDesign. Go back, change DC-AC ratio, insert a secondary inverter, and just go back and forth to the preview tab to achieve a result that you agree on. So let's click on Create Design. And a final results is the following. This will take around 40 seconds, so very quickly, and we will have all this documentation personalized and specifically for this design. So as we can see, we have the layout here, power, specific production, PR, GCR, area installed. We can go and see again site details on our slope tool, then meteorological data, configuration here, and finally the detail losses for the first year, as well as my energy injected to the grid each month and my performance ratio. So now let's go ahead and see some of our documents, open them and check them out. We offer as a standard methodologies, as you can see here. The design one goes over everything I have explained today. The electrical methodology explains all electrical configuration and cabling sizing. Then we have the BOQ methodology that explains how we've done all the estimations for a final BOQ. And finally, the energy yield methodology includes how is our production model configured. So every equation, parameter we haven't shown in the interface, but that we also consider, etc. So next, let's go and see our energy yield report, for example. Great, so I hope everyone can see my screen. If not, please say so. And I will start showing you the energy yield methodology. Each one of the clients have their logo in our in PVDesign. So each one of the documents will include that logo. Let's see the contents of the energy report. I'm going to scroll down and show you a bit of each section, but of course, if you don't see everything, this is just for you to have a general idea of what it includes. So we will have an introduction, then site details, solar resource, description of the PV plan, including all our equipment, the general layout, and now I'm going to stop at point 7, the losses. This specific point will include a summary of all the losses that have been applied to this plant, with a brief description and the specific value regarding this loss for your design. So for transposition, we will have a gain of 33.38%, and this goes all through each one of the losses. And finally, in point 8, we will apply all these percentages to the GHI. So when all these percentages are applied, we will have our final energy injected to the grid. Next, we will have the same energy, but for each one of the years of the lifespan of our plant. And that will be all for the energy report. And let's go check more documents. We have 4 spreadsheets available, project sheets. It's going to include basic characteristics of our plant and design parameters. Then we have the VOQ that is as follows. We have main equipment, civil works, electrical system, and finally miscellaneous. And we have all the quantities for each one of this equipment. So we also provide a CAPEX tool to figure out preliminary CAPEX value. For example, if we insert a value here, we will have a total and a specific price as well as a final CAPEX value. Next, let's check our energy yield results. So for the energy yield results, we have a first tab with main characteristics and the system losses for the first year, as we just saw earlier. Next, we will have the hourly production. So in this tab here, we will have the energy production for each hour of each year of the lifespan of our plant. Finally, the last spreadsheet is a listing of cables. I'm not going to open it because it's I can explain it very simply for you. So the listing of cables will include a relation of all the cables that participate in our final layout, and will include, for example, cross-section, material use, length, and the first column is going to be a code that will refer for to each specific cable. So if we copy that code and search for that code in our final general layout in AutoCAD, for example, we can visualize that specific cable. So let's go ahead and see how our general layout looks like. As you can see here, we will have all the structures positioned, fences, roads, interconnection, power station, this red boxes that you can see, even combiner boxes, etc. We also provide with the printable version of the layout, and as you can see here, it will include brief characteristics like rated power, UTM convergence, DC-AC ratio, etc. Then a legend, and finally our logo, the client, and some other data. We get into the end of the software, so bear with me a bit more. Then we will have the terrain slopes as we saw before, and finally the SLDs in PDF or CAD. I want to repeat again that all documentation is editable and is available in Portuguese. So let's open a single line diagram for you to see. This one's the one for medium voltage, and it includes 11 pages of how our power stations are interconnected, the characteristics of the cables and other parameters, as well as some notes, the legend, and again, our logo and our logo and the client's logo. So yeah, that's all for the software demonstration. Let's go back to the presentation now. So I hope you enjoyed this software demonstration. Please, if I have piqued your interest, we'll be glad to offer you a 14-day free trial. Just go into our website and ask for your personal demonstration, where we will have the same process in the software, but a bit more in detail. After that, you will have 14 days to try the software out with your own projects. So now it's time for the Q&A. Thank you for your attention. If you would like to know more about PV design, please do not hesitate in visiting us at ratedpower.com, write us at biz@ratedpower, or just call us to this number here. Thank you very much.
Thank you, Natalia. The presentation was very clear. So now we have some questions. João Paulo is asking if the PV design supports projects with technologies like microinverters and optimizers.
No, we do not. We do not. We haven't seen that microinverters are being widely used in utility scale projects. We optimize sites from over 1 megawatt, so we're not using microinverters at the moment. We do not support, for example, rooftop designs, but yeah. So I hope I have answered your question.
Yes, it's more specific. It's like one area of PV systems, right?
It's for utility scales, big companies, big plants.
Okay, another question was about that. If it's possible to use the software for roofs, like BIPV, I think you have already answered that.
Yeah.
And what about floating plants?
Okay, floating. We are, as I said before, in constant development of new features, and we've seen that floating is, in fact, something that our clients are interested. We have at the moment a team of engineers working in which parameters should we include in the software to accurately make floating PV designs. And it's not yet implemented in the software, but we hope to have it soon. It's a thing we have in mind, basically.
Okay, yeah, maybe in the future. So I'll just translate a little bit what we are talking
Of
about.
course.
Eu perguntei para a Natalia se eles trabalhavam com microinversores e otimizadores, né, no software, mas ela me respondeu que o PV Design é mais para uma área específica, né, de grandes sistemas, então essa parte de microinversores e otimizadores não está inclusa. E eles também não incluem sistemas em telhados, mas em sistemas em flutuantes, eles já estão pensando, né, os engenheiros já estão pensando em como colocar isso no sistema, então talvez aí no futuro já tenha alguma coisa para sistemas flutuantes. We have another question. Ruben is asking, what are the strengths of PV design compared to other softwares, other PV softwares?
Okay, yeah, sure. Trends, I think does he mean like in relation to energy production?
I think generally, like why choose PV design and not another software?
Okay, because okay, we aspire to give the best attention possible. We have a support team that's constantly checking our clients' designs and trying to reach our clients to optimize their designs and the client's use of the software. We are in constantly developing new features, and we aspire to have a software that we believe in and that we feel it's positive for the industry. Like our logo is accelerating photovoltaics, and we aspire to do so.
Okay. And what about the uncertainties of the model? I think in this case, more about the energy generation.
Okay, so in terms of energy production, we are not yet maybe the standard in the industry to generate energy production, but we have seen that our results are really similar to the industry standard. So with a very, very small margin of error. This, of course, we believe that the best for accuracy, the most important factor is the meteorological data you're working with. So in terms of energy model, if people are interested, they can write directly to me and I will share the things we take into account on our equations.
Então, só traduzindo, né, eu perguntei agora para a Natalia quais seriam os pontos fortes do PV Design comparado com outros softwares. Ela falou que eles têm um setor de suporte bem preparado, né, e sempre atento ao cliente, né, a trazer os melhor retorno para o cliente, né, então acho que isso é bem importante, né, em todas as empresas. E com relação às incertezas do modelo, ela falou que chega bem perto, né, do que a indústria precisa, né, do que a indústria pede. E se alguém tiver mais alguma dúvida quanto a isso, né, ela pode explicar melhor, pode perguntar para ela diretamente, né, pelo e-mail ali, que ela pode trazer uma explicação mais completa. Okay, Natalia.
I would like to ask one last thing. We have Portuguese speakers at Rated Power. So just if you contact us, we will refer them to you. Our CEO, for example, worked and lived 7 years in Fortaleza, Sao Paulo. So yeah, we have ties to Brazil.
Ok. A Natália está explicando para a gente que eles têm também pessoas que falam português na empresa, né? Então, se quiser mandar uma pergunta, quiser conversar com alguém que fala português, também é possível, né? Até porque o programa ele também gera os outputs, né? Também os resultados ali eles também saem em português. Então, também é possível, né? Mesmo se não conseguir se comunicar muito bem em inglês, também tem essa possibilidade lá. E só para deixar claro, pessoal, a gente está gravando, né? Todas as palestras, elas vão ser liberadas nas próximas semanas aí. E a palestra do PVDesign, a gente vai colocar a legenda, né? Então, quem quiser assistir novamente com mais calma, vai estar a legenda em português ali, então, para facilitar o pessoal. So, Natalia, I was just explaining that we are recording our lectures and we will make it available in the next weeks. And we will put subtitles in Portuguese for people who want to see it again, to see everything slowly. So,
of course, sounds great.
Okay, I think that's it. We'd like to thank you again. We really appreciate Rated Power in our event.
We are glad that you had us, and thank you very much.
Okay. Bye, Natalia.
Goodbye. Ciao.